humble abode. I like to call it the Davenport, but that's just a little nickname some of my friends gave it. We're here today... Wait, what did you say you were here for again? Oh, that's right, to learn about cellular respiration. Well, first of all, make yourself at home. Well, first of all, it starts with a process called glycolysis, and then it goes to pyruvate oxidation. After pyruvate oxidation, we have the Krebs cycle, and then finally we finish it with the electron transport chain. Oh, and we're also going to be learning about anaerobic respiration, also known as fermentation. The first part of glycolysis is the energy investment phase, in which two ATP molecules come in, leaving behind two inorganic phosphates. The ATP leaves, thus turning it into ADP, which then leaves. Then NAD comes in. It receives an electron, turning it into NADH. That also leaves. Then an ADP molecule, two ADP molecules come back in, picking both of the inorganic phosphates up and then leaving. Next, the glucose molecule divides into two, releasing CO2 and H2O. Pyruvate is now into two molecules. Remember those pyruvate molecules we talked about earlier? Well, two coenzyme A have come in and attached themselves to those molecules. Also, NAD+ has come in, picking up electrons and leaving as NADH. The next step in the cycle is the Krebs cycle, and we have acetyl-CoA. The coenzyme A leaves. This happens 4 times throughout. Next, NAD+ enters, picks up an electron, leaving as NADH plus H+. This happens 8 times throughout. Next, 2 molecules of H2O come in. They just kind of hang out. Then, FAD+ comes in, picking up an electron and leaving as FADH2. This happens 2 times throughout. Next, 2 molecules of GDP come in, and they leave as GTP, which then transfers an organic phosphate to the ATP, or to ADP, making it ATP. Silly me. Finally, the 2 pyruvate molecules, because there's 2, even though I'm just holding 1 for demonstration purposes, end up, or push out, 6 molecules of CO2. Canada. Our next step is the electron transport chain, which electrons enter the transport chain through protein 1, where NADH plus H plus gives an electron to protein 1, changing its shape, thus pushing an H plus ion through and leaving as NAD plus. The electrons can enter that way, or through FADH2 through protein 2, where it gives an electron to protein 2. Thus becoming FAD+. So either way, whichever one the electrons enter, the electrons go from Q to protein 3. Once they've reached protein 3, the electron changes its shape, pushing an H plus ion through. Then it moves to protein CC, and finally to protein 4. Where when it reaches protein 4, not only does it change its shape, pushing an H plus ion through, O2 is bonded with an H plus ion, creating a molecule of H2O. Notice the concentration gradient, how there's all these H plus ions on top. They want to get down to the bottom, so they go through the ATP synthase. Once they're through there, they're bonded with ADP, making ATP.
Now, Seth, answer me this. Where did the NADH and the FADH2 come from?
Oh, I almost forgot. They came from the Krebs cycle, which was the previous step in our process. sometimes in cellular respiration, the electron transport chain gets backed up, thus changing it to anaerobic cellular respiration, in which a molecule of NADH plus H comes to the molecule of pyruvate, drops off the electron, and leaves as NAD+, leaving us with lactic acid. Or, before any of that happens, a molecule of CO2 leaves the molecule of pyruvate, and then the NADH plus H plus comes in, dropping off its electron, leaving as NAD+, and now we have alcohol. Thank you for joining me on this riveting experience of cellular respiration. We laughed, and we cried, and we laughed. I hope you'll join me next time when I teach you how to play basketball. First you have glycolysis, and then you got pyruvate oxidation, and after that we got the Krebs cycle. Yeah. And after that we got the electron transport chain. Yeah.
Look at this dog, such a cute puppy. Cute puppy. I do not. Come here.